So in our last video, we talked about the different types of bias and things that we would want to avoid. So in this video, we're going to talk about some other kinds of sampling methods. We're going to focus on some good sampling methods, and then talk about some other methods and talk about the pros and cons of those other methods. So there are other sampling methods that we are not going to cover. We're only going to cover a few different options. The first one we're going to talk about is what's called a simple random sample. It's probably the easiest one to understand, and students have a tendency to like this one because it seems the most fair. I like for students to think of simple random sampling as really just a big raffle. So imagine a raffle that we each have one ticket in, and we randomly pull out so many tickets, and those are our winners. That's the idea of what simple random sampling does. So what that means is that we're going to start with a list of all elements in our population. And then from that, we're going to randomly select so many of them. And for so many, we're going to go and use that symbol we learned earlier in this module of n. Remember, this little n is going to be our sample size. And we're going to select that many people, and this is our sample. So one of the easiest ones to understand, seems nice and fair because everyone has the same chance of being selected, assuming of course we are each only listed in the population one time. The next type of method is stratified sampling. And it starts with the same idea of the simple random sampling. We're going to start with a list of all elements in our population. But then we're going to do something else first. This is where it's different. We're going to break this list up into homogeneous groups. And these groups are also referred to as strata, which is where the idea of stratified sampling comes from. Now when I talk about into this homogeneous groups, there's an important thing to mention here. This grouping that we create is not on the variable you're collecting. So for example, I might break people up into men and women. But if my goal is to record their gender, I don't want to break them up into men and women because that's the variable that I'm actually looking at here. Now that we've broken them up into separate groups, we're going to randomly choose some from each group. So sort of a visual difference is up here, we just have our one big raffle pot, and we randomly pull out so many of them. Whereas with a stratified sample, I'm now going to have these different buckets, and from each of them, I'm going to pull out some instead. A benefit to doing a stratified sample is if you want to ensure that a certain type of group actually does show up, that maybe it is something that you're interested in. So for example, I might want to see how people with a certain disease versus those people without that disease react to a certain medication. Well, maybe this disease is relatively rare. And if I were to just take a random sample of everybody, I wouldn't get a lot of people with that disease. And so I might say, well, I'm going to sample 200 people with the disease and 200 people without the disease, and then compare the two. And so it allows us to make sure that we have a certain type of group show up, especially if it's something we're interested in. The last good method that we're going to talk about is called systematic sampling. And just like it sounds, there's a system to it. And it starts the same way as our others did. We're going to start with a list of all elements in our population. Then, of course, it's the second step that's a little bit different. We're going to randomly choose the first element from the first K elements. And this idea of K seems a little weird at first. But so for example, I might look at my first 10 elements, and then K would be 10. And from those 10, I'm going to randomly choose the first one. So I might just have a computer randomly choose a number between 1 and 10 for me. Okay, that picks my first element. Because then what I do after that is I sample every kth thereafter. So if I was sampled one of my first 10 elements, then I'd sample every 10th person element after that. So for example, if I sampled the third element, then I'd sample the 13th element, then the 23rd, then the 33rd, and so on until I was down out of my list. So the random part happens with that first element, but once you've chosen the first element, you know all of your other elements that you're going to pick. All right, so definitely some good methods that we can use there. But let's talk about some other methods that we see quite often and talk about the pros and cons of them. And both of these are just like the terms are. So the first one is convenient sampling, and it just means that we simply sample those that are convenient. So some different examples that fall into this. So I might just do a quick class poll while I'm teaching because they're already there. I might stand outside the grocery store and just sample those people that happen to be coming outside the grocery store. Right, they just happen to be walking by, so they're part of my sample. Now, some good things about that, it's really easy, right? So it's a nice thing to be able to do that way. Of course, we want to be careful of having bias. So if I'm just doing a class poll in one of my classes, then I don't want my question to be, have you ever taken a stats class? Because I teach only statistics classes. So that would be a biased sample. But if instead, for example, if I was just looking at measuring the height of people, okay, it's probably not going to be that big of a deal. Now our other type of other method here is a volunteer sample, and you simply ask for volunteers. And let me make sure I'm specific here about this. That means that people seek out the researcher to participate. Because everyone always has to volunteer to complete the survey, but it's how it's being asked. If I ask you, will you answer my survey, that's not a volunteer sample. What a volunteer sample means is that I kind of maybe put out a little bulletin, hey, I'm looking for people to fill out my survey, and those people come to me instead. But I don't specifically target certain people to be part of my sample. So you're asking for volunteers instead. So some examples of this. A lot of news polls would fall into this category because a lot of times people have to call in to give their opinion about something. Different websites where people go out and rate things. So for example, like Rate My Professor would be an example of that. Or if you've ever gone out and maybe filled out a review for a product you got on Amazon. Right, those are volunteer samples because people are going out there and choosing to fill that out. Another example of this would be medical trials. Right, medical trials, of course, have a little bit more screening involved with them to probably make them a little bit better. They make sure you should be participating in your survey. Let's see, another volunteer sample. One of my favorite are those "How's My Driving" bumper stickers that you see on trucks and stuff like that. Now, when I look at volunteer samples, for most of them, I usually expect them to be biased because there's a certain type of people who are going to seek them out. So let's go ahead and talk about a couple of these. So Rate My Professor is a good example of that. Now, first of all, it is not my intent to completely tell you to never use Rate My Professor. But I want you to know what you're looking at when you go there. Who are the people that choose to fill out the Rate My Professor evaluations? Usually it's ones that have a very strong opinion, either a very strong positive opinion about a professor or a very strong negative opinion about a professor. So a lot of times you'll see on there either this professor was awful or they were awesome. And you're really not getting a lot of that middle group there. Medical trials are actually a little bit better because of, again, all the screening that's involved. So those are usually a lot more trustworthy. But let's talk about the "How's My Driving" bumper sticker. Now, if you saw one of those, when are you going to call? Are you going to call and say, you know, that truck driver had the best right turn I have ever seen? Probably not. Usually the people that are going to call in are the people that just got cut off or very angry. Right? But if we know what we're looking at, you can still get some useful information. So with the "How's My Driving" bumper sticker, what I can look at is how frequent are those calls coming in. Right? Is this truck driver getting a call every single day that he's made someone angry, or is it only happening once a week? Right? So I can still look at this information as long as I know what I'm looking at. Right? Same thing with the Rate My Professor. You just need to know that you're looking at pretty strong opinions and that the truth probably lies somewhere more in the middle. Right, so that's some examples of the different types of sampling methods. You could, of course, see combinations of these different types of sampling methods. For example, I could stand outside of a grocery store and ask every 10th person that comes out to fill out my survey. So I'm standing outside the grocery store, which is very convenient, but I'm also employing a systematic sampling method by sampling every 10th person. So again, you may see multiple ideas show up with the sampling methods as well. We want to focus on the good things that come from these sampling methods and of course pay attention to the bad things that could result because of our sampling method.